Hi, welcome. My name is Aditthio Chanra. This time we will discuss computers and three logic gates. Imagine a computer on your desk. This computer can perform a variety of tasks, from calculating numbers to processing videos, playing games, and even helping you talk to other people around the world. However, what is inside a computer? What makes it so sophisticated? Inside a computer, there is a small world full of electronic components working in harmony to carry out our commands. But what's really going on behind the scenes? How can computers understand and execute our commands? The answer lies in binary logic, the combination of 0 and 1. These two simple numbers are computer language. Let's get inside a computer and see how these tiny elements. Our journey begins at the motherboard. The motherboard is the center of all activity on your computer. Here there is a processor, memory, and various other components that are connected to each other through small electrical paths called circuits. When we zoom in on one part of this chip, we find tiny elements called transistors. Transistors are important electronic components that can be found by the billions in a modern processor. Transistors are electronic switches. They can open or close electrical pathways, creating combinations of the numbers 0 and 1. This is the basis of computer logic. A transistor has three main parts: gate, source, and drain. The gate functions like a door handle, controlling whether current can flow from the source to the drain. Let's take a closer look at how it works. Think of a transistor like a water faucet. The gate is the tap handle, and the electric current is the flowing water. When we turn on the voltage at the gate, the transistor opens, allowing electric current to flow from source to drain. This represents the number 1. However, if the voltage on the gate is stopped, the transistor closes, preventing current from flowing. This represents the number 0. This simple principle allows transistors to become the basis for binary logic, which is the language of computers. With billions of transistors working together, computers can execute complex commands with just a combination of 0 and 1. These transistors can also be combined to form more complex structures, such as logic gates. Let's see how logic gates work. First, we have the NOT gate, the simplest logic gate. The task is the input elbow. If the input is 1, the output is 0. Conversely, if the input is 0, the output will be 1. Imagine you have a light switch flipped. If you press the switch to turn off the light turns on instead. That's how NOT gate works. It is the basis for many logical operations in computers. Next, we have the AND gate. This logic gate only produces the output 1 if both inputs are 1. In all other cases, the output is 0. For example, imagine you have two buttons that must be pressed at the same time for a light to turn on. If only one button is pressed, the light will not turn on. And gates are used in computers to ensure that two specific conditions are met before continuing operation. This gate is made by combining several transistors. When both transistors are active, current can flow, producing the output 1. Lastly, we have the OR gate. This logic gate produces an output of 1 if at least one of its inputs is 1. Only if both inputs are 0, the output will also be 0. Imagine you have two buttons to turn on the lights. If either button is pressed, the light will turn on. OR gate provides flexibility in logical decision-making in computers. All of these logic gates, NOT, and OR, are built using transistors, and they are the basis of all logic operations in modern computers. Transistors and logic gates are the foundation of modern technology. They work together to enable computers to understand and process data. From simple principles like electronic switches, we get systems capable of carrying out billions of operations per second. Behind the scenes, this video was created using Blender, a powerful 3D animation software. This process involves modeling, animation, and rendering, all of which aim to explain the technology in a way that is easy to understand. Thank you for joining this journey. If you want more educational content like this, don't forget to like this video and subscribe to our channel.